Your lesson today is on graphing proportional relationships. Let's take a look at a couple relationships given in table form. But as a reminder, a proportional relationship between two quantities is when the two quantities vary directly to one another. As one quantity changes at a constant rate, the other quantity changes at a constant rate as well. And we can also say this as direct variation. Some of you may have heard that, maybe not. So for example, we have gas. We have a table of the cost of gas. It looks like it's $2.88 for 1 gallon, $5.76 for 2 gallons, $8.64 for 3 gallons, and $11.52 for 4 gallons. The question is then, what is the cost of 0 gallons? Well, if you don't buy any gas, it costs no money, right? So $0. What it looks like, if you buy gas, it costs $2.88 per 1 gallon. A car travels at a constant rate at 70 miles per hour. How far does the car travel at 0 hours? Well, no time's gone by. The car's gone nowhere. So it's gone 0 miles. These are examples of proportional relationships. We have a constant rate in each table. Now we're going to graph those relationships that we saw on the previous page. So we have the effective gas on total cost on the left, and we have the effective time on miles on the right. So bear with me, guys. I'm going to go ahead and put in what we have. We have 1 gallon, 2 gallons, 3 gallons, 4 gallons. Put gallons on the bottom. I'm going to go ahead and space this out. So we have 288 there, 576 there. 1 second. We have 864 and 1152. And of course, we have our 0, 0 point. So we plot that. We plot there. We plot there and there. I'm going to skip my line tool. Let's see if I drew it straight. Pretty good straight line by freehand. So there we go. We have a straight line for that relationship. Going to our miles one, our traveling. I'm going to again skip lines to space it out. So we talked about 4 miles, or 4 hours, excuse me. And we have 70 miles, 140 miles, 210 miles, and 280 miles. And of course, 0, 0. No time gone by, we haven't gone anywhere. We have 170, 2, 140, 3, 210, 4, 280. Which again gives us a straight line. I'm a little bit off, but you guys get the idea. So what two similarities, requirements are present in these two proportional relationships when they're graphed? So 2 things. 1, we have straight lines. And the other thing they have in common, if you haven't figured it out yet, they go through the origin, which is the point 0, 0. These are requirements for any proportional relationships. If we don't see both of these on graphed lines, then the lines do not represent proportions. So we're going to determine if these tables, these relationships are proportions. So looking again at miles traveled over time, and I think we can tell this is proportional. It's proportional because, so we'll say yes, our miles increase at a constant rate as our hours increase. Give me a second to write this up. Right, as the hours increase. Also, think about the context of the relationship. If we travel 0 hours, well, we've gone nowhere. So that point 0, 0 is there as well. Now, if we graph this, we're going to set this up. We've got our 1, 2, 3, 4, and we're going 50 miles per hour. We have our 0, 0 point, our point at 150, 2, 100, 3, 150, and 4, 200. You guys can graph how you want to, but I think, the easier graph we can make, the better. So the slope of the line, remember from a couple units ago, we have rise over run. So we go up 50 over 1. Our slope is 50, which makes the equation of this line y equals 50x. Whatever the hours are, which is the x, multiplied by 50, gives us our y. That's our slope-intercept equation. Again, going back a couple units when we learn how to do these. Finally, does this table show a proportional relationship? Why or why not? And the answer here is no. Because we don't have a constant rate. See, the jump here is going by 40. We have 40 again. Ooh, we're going 60 here. So the reason why we can say that there is not a constant rate. You can, expand on that as you want to. You can word it differently. Left out the word not, which is kind of important there. There's not a constant rate. And this leads us into two examples that you should try on your own. So why don't you go ahead and pause the videos as I work through, answer these questions. The following tables determine if they show proportion. If yes, we're going to graph it and write the equation of the line. So the video's not paused, it should be. For the first one, the answer is yes. We're jumping by 45 each time. We have a constant rate. So to graph that, again, go my 1, 2, 3, 4. I'm going to jump my lines by that constant rate. Every other to space it out, make it easier to see. Here we're at 0, 0 point. Here we got 145, 2, 90 right there. 3, 135, and 4, 180. And there we go. Our slope is 45, which makes the equation y equals 45x. And for our second one, let's see, we're going up 45, up 50. You know what? We're going to stop right there. Not a proportion, no constant rate. This concludes your lesson on proportions in graphs and tables for that matter.